Okay, so question number 6 asks, is nitronium NO2 plus polar or nonpolar? Okay, so first let's draw the Lewis structure for this ion. So we'll find the total number of valence electrons. So nitrogen has 5 and oxygen has 6. And since there are 2 oxygen atoms, we multiply this by 2. And also notice that our overall ion has a positive charge. So that means we need to subtract an electron from our total count. So adding these values up, we get a total of 16 electrons. Yep. And now we need to draw out a skeletal structure for this compound. So nitrogen will be our central atom. And I'm just going to draw 2 single bonds to the oxygens. And let's show all the lone pairs and count out how many electrons I've drawn so far. So notice that we have our 16, but our nitrogen doesn't have a full octet yet. I'm just going to bring one of these values down to make a double bond. Okay, so now we have a structure that has also 16, but again, our nitrogen doesn't have a full octet. So let's draw another double bond to one of the oxygens. So now we have kind of like this linear structure. And this is where we find our positive charge. So let me show how we can calculate that charge by using the formal charge equation. This is the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. For both of the oxygens, they have 6 valence electrons. For non-bonding electrons, so the lone pairs, and each of them have 2 bonds, so that means we have 4 bonding electrons divided by 2. So both of the oxygens will be neutral. And for our nitrogen, nitrogen has 5 valence electrons. There are no lone pairs in this structure. And there are 8 bonding electrons divided by 2. So this is how we know that nitrogen will be the one to carry the positive charge. Okay, so since we have a charge of this on this compound, anytime an ion is charged, we have a polar molecule. Okay, so let's see what the junior tutor said. A polar molecule is a molecule that has a dipole moment different from 0 because it has a non-uniform distribution of electrons. They found the electronegativity difference to be polar because it has a value of 0.5. And they kind of showed out all their steps. And determined the correct Lewis structure. And then noted that the bonds cancel each other out. So they wrote that the nitronium ion is nonpolar because of this. I'm just going to say that the explanation is correct. However, for charged molecules, they are considered polar.